Welcome to Tech Talk Thursday, Season 4, Episode 4. This week, we're going to take a look back at some of the highlights of Q2. As one of my friends and colleagues likes to say, from my home to yours. And we are literally sitting in my garden here in Somerset, England, bringing you this program. Q2 was an extremely busy time for global SMT and packaging, and it kicked off with an excellent panel discussion on thermal interface materials. Andy Mackey from Indium Corporation was a guest on that show, and he told us about a new job title that seems to have appeared in the EMS world. Take a listen.
The things that's really driving this is the appearance of the person known as the thermal architect. And from a system level, this is somebody who's looking at every aspect of it, from the die level to the substrate level, if heat's being removed through the hubs, through the substrate, through the backside of the die, through TIM 0 or TIM 1, and then the TIM 2 and the various gap fillers and heat sinks and so on that carry the heat away from the back of that. And so that thermal architect has responsibility for everything from soup to nuts, and it's no longer a sort of the device guy or the wafer guy doing one particular just looking at one particular aspect, and then the system level being taken care of by somebody else. It's the whole issue of thermal management is being taken care of from a system level, and that's leading to a lot more specificity around design and procurement of the thermal interface material.
Another great panel in April was eliminating paste-related defects. And we already knew how temperature and humidity affects the performance of paste in the printing process, but altitude, that was a new one.
One thing that we have noticed when we're jetting paste though, is that when you actually have your company at a higher altitude, so if your industry is at a higher altitude, we've seen jetting results different at sea level than if you do it in Denver, for example. Modify cassette models and modify the way that you jet to be able to get the same results using the same material at different altitudes. One
of the biggest business announcements of the quarter was the acquisition of HK Wentworth by McDermott Alpha. Now, many of you may not be familiar with the name HK Wentworth, but they are, of course, the parent company of Electrolube, which is a very well-known brand in our industry. I asked Ron Jakeman, the Group Managing Director of Electrolube, what was the reason behind the sale? So Ron, if I can ask you, I mean, what were your reasons for selling, essentially, or for agreeing to the acquisition?
As I mentioned earlier, we've been looking at I've been talking to the Kingsley family about what we're going to do for probably the past 5 years, and we looked at all sort of options, but at the end of the day, they decided that they really wanted to sell the company, and so it was then a question of finding the best home for it, and allowing the brands to continue. And I think once Elements came into the frame via our advisors at Elantra, there was a lot of excitement because they haven't got our product range. They didn't have our product range. So that was obviously very favourable in terms of Electrolube going forward, and the size of Elements sort of they've actually will enable us to grow, because one of the problems was resources. We're only a relatively small British family company, so being linked into Elements with their size, their expertise, they've got 4,000 plus people, technical specialists in all areas, and administration specialists as well. So it will allow Electrolube to shake off some of the shackles and to sort of flourish and grow. And that's why I was very pleased when the deal was concluded, really. I think it's a good home.
June 16th was a major date on the calendar for Global SMT and Packaging. That was our low temperature soldering conference, which was tremendously successful. It started off with a keynote speech from Tadashi Khashoggi from Lenovo in Japan, and was followed by 14 sessions in 2 parallel tracks. And the following day, of course, we had a workshop which was performed by the world-known Bob Willis from his mission control in Essex, England. The week following the low temperature soldering conference, we had a fascinating debate on failure analysis. And when it came to the Q&A session following the panel discussion, I had a surprise guest visit my studio. Michael Ford dropped in and told us about some of the new things that are appearing very shortly from IPC.
A great debate there so far, and guess who's just walked into my studio? I have a visitor. What do you call it? Michael Ford's just joined us here, and it's great that Michael's here because it relates to one of the questions that has been asked by the audience. So I will I'll ask this question first, which comes in from Jim Farrell, and he's asking a comment based on an earlier conversation. He says, in the mill aero industry, we demand full history on circuit assemblies, but it's not free by any means, and it limits our supplier choice drastically. Now, during the debate there, of course, we did touch on that topic. Was the ability to be able to capture the board's manufacturing data in the event of a field failure and being able to return it. And it appears that there is actually something in the works, which Michael is going to allude to.
Thank you. Yeah, we've been thinking about component provenance and life cycle using the digital twin. And okay, forget digital twin of design manufacturing, that's one thing, but go out into the market through the life cycle. So, for example, you have a product that is being made, it's working fine, it has a lot of semiconductors in it, for example. What we're thinking of doing is for each semiconductor, we are reserving a very, very small area within that semiconductor, separated from the normal working, in which we would embed an immutable ID so that we could tell each individual chip apart from others. Right. And alongside that, start to record history. So, for example, maybe there is a product, it's working fine, but the semiconductor exhibits some problems. A lot of semiconductors have design built in such that they can kind of log out of certain area of it and start using another area of silicon, and so it continues to work. But it can start to log issues into this small area of memory. And you treat it like an RFID chip without the RF. It's actually just a bus connection into the chip, completely separate to everything else. You connect to the chip onto a board and to all of the other chips. You now have a digital fingerprint of a circuit board. You then put that circuit board into a controller. You've got a digital fingerprint of the controller, and then up to the final product. But the nice thing is that all of this works without the device being powered on at all. So that, for example, if there was a catastrophic failure of that product, you would be able to go in with a 2-pin connection and read the history of what caused the problem from the point of view of each semiconductor on that card.
Wow, that's really interesting. Now, Rob, would that make your life easier?
It could, in that it would give us more data to work from. It would give us more clues forensically that we could then validate and verify using things like imaging technology or flying probe or what have you. The question I would have is whether you can get all the chip manufacturers to sign on to that in a timely way, such that it would cover the entire board. I suspect initially you might get bits and pieces of information. So if a particular device fails, you might have a clue as to that failure. But if the other, I don't know, 60, 70% of the active parts on the board don't have that RFID, so to speak, then you're still to some degree in the dark.
But as I understand it, this is looking at the the life or the history of that device, that component in that board. It doesn't actually tell you what the board has been doing. So there is a degree of anonymity there, is there?
Oh yeah, it is. The chip knows what's happening from its own perspective, and you can start to combine bits of information from other chips. The important thing to make this, let's say, widespread over different devices and different manufacturers is the fact it's an IPC standard, or part of an IPC standard.
Right.
So that for the critical components where you would want to understand where did the failure happen, then you would have the evidence to go forward forensically, as you said, and start to piece together the kind of thing that took place.
Right, okay.
So that wraps it up for this week's Tech Talk Thursday. Fascinating look at some of the panels and Tech Talks that we've had over the last quarter, but there are many more, so please take the time to go onto the website and have a look. Till then, I hope you'll join us next week when we'll be back with more information from the industry.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.